Apple has released a new depth estimation model for metric depth estimation. The model is called Depth Pro. In this video, we will see how we can estimate real distance to objects with Depth Pro and YOLO11 model. We will take an input image, or we will input an image to the Depth Pro model, and the Depth Pro model will give us the depth map. From the details shared in the paper, the Depth Pro model is fast and it produces a 2.25 megapixel depth map in 0.3 seconds on a standard GPU. So over here you can see we have some examples of birds and cages. So we can see over here when the object is closer to the camera, we can see we have the red color. And when the object moves away from the camera, you can see the colors become cold, or you can see we are just getting a blue color when the object is far away from the camera. And when the object is closer to the camera, you can see over here we are getting a red color. When they have here we have the cat and camera. So these objects are very closer to the camera. So you can see we have the red colors, and when the objects move away from the camera, then you can see the colors become cold, or we are getting blue color. So over here you can see we are just getting a very good metric depth map. From these examples we can see over here. Before we go ahead, we can also discuss some limitations of the Depth Pro model. So the model, this Depth Pro model does not work in real time. This model works only on a single image. Currently this model does not work on video. But this is a good model to get metric depth map. So in the further work, like after some time, we will have other models available which will also work on videos as well. But currently, this model only gives metric depth map on a single image. Okay. So in this tutorial, we will estimate real distance to objects with ML Depth Pro model and YOLO11 model. So we are just going to find the distances of the people walking in from the camera. Okay. So as I told you, when we input an image to the Depth Pro model, the model gives us the depth map like this, as you can see over here, and we also get metric depth values. So whenever we input an image to the Depth Pro model, we get two things. One is the metric depth map, which is you can see over here. This is the depth map we are just getting, and we also get the metric depth values. Which means, so what are metric depth values? Metric depth values are basically, you can say, metric depth value means for every single pixel, we are going to get a value in meters. Okay, like how far this is from the camera. Okay, so for every single pixel, we get a value in meters. Okay, and when we combine the Depth Pro model with YOLO11, then we can see calculate like how far this object is from the camera. Like we can say that this person is 2.4 meters away from the camera. The second person is 3 meters away from the camera, and the fourth person is 5 meters away from the camera. Okay, so here you can see we have the we are being provided by the steps like how we can download the Depth Pro model weights and how we can run this model in the command line, and we can generate the depth map. And here we have also provided instructions to run this Python script in Python script as well. So I have already prepared a Google Colab notebook where we will estimate real distance to object with ML Depth Pro and YOLO11 model, which is being provided by Ultralytics, and the Depth Pro model is being provided by Apple. Okay, so let me just show you the Google Colab notebook now. So here you can see our Google Colab notebook and it's ready. So over here, you can see this is the GitHub repo. So first of all, I will just copy the URL, okay, over from here. And in the first step, I just need to clone the GitHub repo of ML Depth Pro. So I will just add this link over here. And before running the script, please make sure that you have selected the runtime as T4 GPU. Google Colab offers free GPU, so we can use it. So in the first step, we need to clone this GitHub repo over here. And you can see the repo is cloned and we have all the files available over here as well. Okay, next we just need to set this clone repo as our current directory. So I will just copy the path from here and just write this. So we are just setting this ML Depth Pro as our current directory. Next, we just need to install all the required packages so that we can run the predictions using Depth Pro model. So I'm just run this And if we run this cell, this will install all the required packages required to run the depth pro model. Okay, so now you can see that all the packages will be installed. So we require all these packages to run the depth pro model. And okay, so next we need to download the depth pro model weights. Okay, so if you just run this cell, this will download the depth pro model weights. All these instructions are being provided in this GitHub repo. You just need to follow the steps over here, and you will be able to, if you just follow these steps, you will be able to run predictions using the depth pro model. Okay, so over here I'm just downloading the depth pro model weights over here. So like the file size is quite large. Like you can see over here, it's around 2 GB. So like this file size is quite large. Like the model weights are quite large in size. Like you can see over here, it is above 2 GB, I believe. So now you can see over here, I'm downloading the depth pro model weights. So it's around 1.77 GB over here, and it's downloaded in the checkpoints depth pro. So over here you can see we have the directory checkpoints, and inside this we have the depth pro model weights over here. Okay, so now let's run the predictions using depth pro model and see what results or what depth map we are getting. Okay, so let's run this now. So before we run this, to run the predictions using the depth pro model and see how the depth map is being generated. But let's run this cell, and this will provide us all the available option, like how we can pass the input image and how we can save the output image. Okay, and how we can skip the display. So if you just want to see all the available options, so you can just run this cell, and so this will provide you all the available options. So now you can see over here, we have all these options available. So if you just write minus hyphen RI, so this will, here you can pass the image path. Over here, you can pass the output path. And by using this, you can skip the display over here. Okay. And if you want to run this, next we will see how we can run predictions using the depth row model and how we can generate a depth map from here. Okay. So let's first look at our present working directory. Okay, and now I will just download some images from the Google Drive into this Google Colab notebook over here. Okay, so I'm just downloading some sample images from Drive into this Google Colab notebook. And now I will just run the predictions with the depth row model, and we will generate a depth map over here. Okay, so now I'm just running predictions with the depth pro model. So I will just write depth pro run. And over here, you can see over here, I have downloaded all these images from my drive into this Google Colab notebook. And all these images are being downloaded over here in this images directory. And you can see we have downloaded all these images over here. So I will just run the depth pro model over here and generate a depth map over here. Okay. So all these are all the images that I have downloaded uh, from the Google Drive into this Google Colab notebook into this directory images. And now I will just generate a depth map using depth model on all of these images. Okay, so I will just pass the name of the images directory over here, and I just want to save the images into the output directory. So then a directory will be created by the name output, and inside this we will have all our output images. So let's run this cell. Okay, so as you can see over here, we can pass the image path, and over here we can pass the output path. So I'm just following the same instruction over here. Okay, so this will take some time as we run the depth pro model on all these images, and we are passing these images as the input, and the depth pro model will generate a depth map. Okay, so I'm currently using Google Colab GPU. It's a free GPU, but if you have used some better GPU, the processing will be even faster. Okay, so now you can see over here we have the output directory over here. Inside this we have all the output images. So like you can see over here, now we have created the depth map over here. Okay, so let's only show you the output image one by one over here. So now you can see over here, when the object that is closer to the camera, we can see a red color in the object is in the red color. And when the object moves away from the camera or the object is far away from the camera, you can see we have the cold colors like blue color. So look, you can see that as the object moves away from the camera, the colors become light. But when the object is very closer to the camera, you can see the color is red. And as the object moves very far away from the camera, the color becomes quite cold. Okay. So similarly, we have some other images as well. So we have three input images, and we have generated the depth map for all these three input images, which you can see over here. So now you can see over here, this is the depth map for the second image, and this is the depth map for the third image. You can see over here. So uh, now you can see we have generated a depth map using depth pro model. Now we will combine the depth pro model with YOLO11 and see how we can estimate real distance to objects. Like we will take an input image and we will see how far this object is from the camera in meters. So we will combine depth pro model and YOLO11 model to calculate real distance or to estimate real distance of objects from the camera. So as I told you, that depth pro model gives us the depth map, but it also gives us the metric depth values, which means that for every single pixel, we are going to get a value in meters, like how far this is from the camera. Okay, so we are not only getting the depth map, we are also getting the metric depth values, which tell us, uh, which is for every pixel, we are just getting value in meters, like how far this is from the camera. Okay, so now if you want to combine the Pro and YOLO11 model, so if you want to use YOLO11 model, we need to install the ultralytics package. So, and for some image processing, we also require the OpenCV Python package as well. Okay, so now I will just download the depth test.py script. Inside this, I have integrated YOLO11 and the depth pro model. So let me just show you the script file as well. So over here, you can see we have the depth test.py file. Inside this, I've integrated YOLO11 and the depth pro model. So we can estimate real distance of objects from the camera. Okay, so now we have integrated YOLO11 and the depth pro model. So from here, you can see that from ultralytics, we are importing YOLO so that we can use the YOLO11 model. And over here we are using the NumPy library, and from here we are also importing the depth pro model. So we are using depth pro model to generate depth map and to get metric depth values in meters, so that we can find out how far this object is from the camera. So here we are just initializing the YOLO11 model. YOLO11 comes with 5 different models. Currently we are using YOLO11 small model. If you want to get better detection results, you can use YOLO11 extra large model, but currently we are just using YOLO11 small model for this demo. And here I'm just defining the image path over here, and here we are just reading the input image over here. And then we are here we are just doing predictions, like we are using YOLO11 model to predict different objects in the image. Okay, over here. But for this specific use case, we only want to detect persons in the image. Okay, so now we are just looking through all the bounding boxes we are getting, like, okay, and we are only interested in the person class. So we are just we only want the bounding boxes around the persons, and like if there are some other objects like cars or handbags or purse, or like some other thing, like if there are some, we don't want to select any other class, like if there is bus. So we are only interested in the person class. We only want to detect person in the image. So here we are just saying that if there is a person in the image, then only draw bounding boxes around that object. Okay, so here you can see we have the YOLO11 code. We are just initializing the YOLO11 model. Then using YOLO11 model, we are doing predictions. Like we are finding out that if there is what different objects we have in the image. Okay, and then we are saying that if there is a person in the image, then only draw bounding boxes around the person. Okay. So next, what we are doing is that we are just loading the your depth pro model and performing pre-processing over here. Okay, so all this code is available of the all the this code of that pro model is available in the ML Pro Github Repo that I showed you. All that code is this code is available over there. You can just find this out. Okay, so then what we are doing is that here you can see that we are just loading the depth pro model, and then we are doing predictions, or you can say that we are generating a depth map using depth pro model. Okay, so here we are just generating a depth map using depth pro model. And I told you that ML depth pro model not only generated the depth map, uh, it also it also provides us the depth values in meters for every single pixel. Okay, so over here can see that we are just passing out the bounding box coordinates and coordinates over here, and we are just trying to find out the you can say that we are just find out the depth metric values. Okay, so we are just trying to find out the depth metric values in meters. Okay, and we will just display this value above each of the bounding box. Okay, so here just this here is just pre-processing code over here, and we are just trying we'll just display the metric depth values, or like how far this object is from the camera in meters above each bounding box. Okay, so over here now we are just generating a depth map. So here is the code to generate the depth map. Okay, so the depth map will be saved in depth color map.jpg, and the image file, output image file where we have calculated how far this object is from the camera will be saved by the name depth.jpg. Okay, so we will generate two images. One will be the what will be the depth map, and other is the image which will contain where where we will have integrated YOLO11 with the ML depth flow model, where uh, we will see how far this object is from the camera. Okay, so currently here we are using YOLO11 and ML depth flow model. Using YOLO11 we are detecting the objects, and using depth flow model we are seeing how far this object is from the camera. So here we have all this code over here, and let's run this script. Okay, so now I will just download this script file which I have explained you from my drive into this Google Colab notebook over here, and let me just run this script now. So this will take some time. Okay, so now you can see that YOLO11 model is being downloaded over here. So let's wait for some time for this script to finish, and then I will show you the results over here. So guys, the script has run successfully, and let's see what results are we getting. So our output is saved by the name depth.jpg, and we have our depth map is saved in depth-color map.jpg. Okay, so first of all, let's see if you are able to estimate a real distance of objects from camera or not. So now you can see over here, I have just passed this image as the input, like this image was passed as the input over here, and here are our results. Like you can see, our results are looking quite promising. Like you can see over here, this person is 6.39 meters away, like this person is 7.10 meters away, this person is 5.13 meters away, and this person is around 10, oh no, this person is around 10 meters away, and this person is around 15.20 meters away. So you can see that results look quite promising, like we are able to estimate real distance of objects from the camera using depth row model and YOLO11 model. So currently we are only focusing on the person class, but you can estimate real distance objects of like you can estimate real distance of other objects as well. Currently we are only focusing on the person class in this tutorial, but you can also estimate real distance of objects from the camera for other classes like bus, cars as well, or for any for camels, or for parrots, or for like handbags, or for like for the skating board, for the cycles, for the cat, for the dog. Like you can do it for different classes as well. Now let me just show you the color map for this as well. So now you can see over here we have the color map. So the objects that are closer to the camera, you can see in the red color, and when the object moves away from the camera, you can see the objects are in the very cold color like green, yellow, and if the object is very far away from the camera, you can see the object, we can see the blue color as well. So that's all. So now in this tutorial, we have seen that how we can estimate real distance of objects from the camera using YOLO11 and depth Pro model. And you can see over here, we are just getting quite promising results. We are able to create the distance like in meters, and we are also able to generate a depth map. From the depth map, we can clearly see that if the object is closer to the camera, this is in the red color. If the object is far away from the camera, you can see the object is in very cold colors as well. And we also seen that the Pro model give us two things. One is the metric uh, depth map, and other are the metric depth values, which tell us how far each pixel is. Like that, we are just getting metric depth values for every single pixel in meters, and using those values, we can estimate distance of objects, different objects from the camera. Okay, so again, I hope you have learned something from this tutorial. If you have any questions, do let me know. Thank you for watching.